Are we alone in the universe, or is there life beyond our blue planet? This grand question has been at the forefront of human curiosity since the dawn of civilization. Before we had the tools to explore the cosmos, our ancestors looked up at the night sky and pondered the existence of life beyond Earth. Philosophers, scientists, writers, and dreamers of all ages have grappled with this question, generating a multitude of theories and beliefs. Some propose that we are unique, a singular oasis of life in a vast cosmic desert. Others suggest that life is a common occurrence, that the universe teems with alien civilizations just beyond our reach. Yet despite our best efforts, we have yet to find definitive proof of extraterrestrial life. But our quest for answers has not been in vain. It has led us to a new frontier, a tantalizing clue in the cosmic puzzle. To answer this question, scientists have been exploring the cosmos, and their search has led them to a new frontier: exoplanets. So what exactly is an exoplanet? Let's dive into that. Exoplanets, short for extrasolar planets, are celestial bodies similar to the planets in our own solar system but orbit stars beyond the sun. The prefix exo comes from the Greek word for outside, so literally, exoplanets are outside planets. They are worlds unto themselves, each with its unique characteristics and mysteries. Exoplanets are as diverse as they are numerous. We categorize them into different types based on their size, composition, and temperature range. Some of the most common types include gas giants, ice giants, and terrestrial planets. Gas giants, much like our Jupiter and Saturn, are enormous planets primarily composed of hydrogen and helium. They are often referred to as failed stars because they share many characteristics with stars, but lack the necessary mass to ignite nuclear fusion at their cores. Ice giants, such as Neptune and Uranus in our solar system, are a bit of a misnomer. They aren't made of ice but rather of heavy elements like oxygen, carbon, and nitrogen. These elements under extreme pressure and low temperatures behave like metals, hence the name ice giants. Last but not least, terrestrial planets. These are rocky worlds much like Earth, Mars, Venus, and Mercury. They are composed mostly of silicate rocks or metals and have solid surfaces. These planets are of particular interest in the search for life, due to their potential to harbor conditions similar to Earth. The sheer scale of exoplanets is mind-boggling. As of now, astronomers have confirmed the existence of over 4,000 exoplanets, and that's just the tip of the iceberg. Each one of these planets holds the potential to answer some of the most profound questions about our universe. Exoplanets, in their vast variety and number, present a tantalizing possibility for the existence of life. As we continue our cosmic journey, these distant worlds remind us how much there is still to explore and understand in the grand tapestry of the cosmos. But how do we find these celestial bodies that are light years away from us? The quest to find exoplanets, planets outside our solar system, is like a cosmic game of hide and seek. These bodies are so far away and so small compared to the stars they orbit that spotting them directly is a monumental task. But don't worry, astronomers have come up with ingenious methods to detect these elusive planets. One of these methods is the transit method. Picture this: you're looking at a distant star and suddenly its light dims ever so slightly. This could be a sign that a planet is passing in front of it, or transiting. By observing these tiny dips in brightness, astronomers can infer the presence of an exoplanet. And not just that, they can even estimate its size and orbit. Incredible, isn't it? Then there's the radial velocity method. This technique is based on the fact that a star doesn't just sit there while its planets go around it. Instead, it performs a small circular dance caused by the gravitational tug of its planets. This dance causes the star's light to shift in color, a phenomenon known as the Doppler effect. By observing these color shifts, astronomers can detect the invisible dance partner, the exoplanet. Let's not forget about direct imaging. This is the most intuitive method, taking a picture of the exoplanet. However, it's also the most challenging because stars are so much brighter than the planets that orbit them. It's like trying to spot a firefly next to a lighthouse. But with the help of advanced technology such as coronagraphs and adaptive optics, astronomers have managed to directly image a handful of exoplanets. With these methods, astronomers have discovered thousands of exoplanets, and the count is still rising. So, the next time you look up at the night sky, remember that each point of light could be a star with its own family of planets, and who knows, one of them might just be our second Earth. Now the big question is, could any of these exoplanets harbor life? As we delve deeper into the cosmos, we are attempting to answer this very question. But before we can even begin to consider the possibility of extraterrestrial life, There are certain criteria an exoplanet must meet to be deemed potentially habitable. Firstly, an exoplanet needs to be in what is often called the Goldilocks zone. This is an area around a star where conditions are just right, not too hot and not too cold, for liquid water to exist on the surface of the planet. After all, as far as we know, water is a fundamental requirement for life, yet being in the Goldilocks zone alone is not enough. The exoplanet also needs to have an atmosphere. Not just any atmosphere though, it must have the right kind of atmosphere, one that can maintain a stable temperature and pressure, protect the planet from harmful cosmic radiation, and possibly contain the right mix of gases to support life. But the presence of water and an appropriate atmosphere are not the sole criteria. The exoplanet's size and mass also matter. These influence whether the planet has a solid surface or if it's a gaseous giant like Jupiter. They also affect the planet's gravity, which can impact its ability to hold on to an atmosphere and water. Scientists use these criteria, and more, to identify potentially habitable exoplanets. They employ powerful space telescopes and complex algorithms to analyze the faint signals these distant worlds send our way. By studying how an exoplanet's light changes as it orbits its star, we can infer its size, mass, and atmospheric composition. This painstaking work is our best shot at finding a second Earth. So, could any of these exoplanets harbor life? We don't know yet. But with every new discovery, we inch closer to answering this grand question. While we have yet to find definitive signs of life, the search is far from over. So, what's next in our quest for a second Earth? Well, the future of exoplanet exploration is as vast and wide as the universe itself, brimming with potential and promising technologies. As we look ahead, we can anticipate an array of upcoming missions and innovations, all aimed at furthering our understanding of these distant worlds. One of the key players in this exciting endeavor is NASA's James Webb Space Telescope, set to launch in the near future. This revolutionary telescope, with its unprecedented power and sensitivity, will enable scientists to study exoplanets in ways we've only dreamed of, from analyzing their atmospheric compositions to detecting potential signs of life. Meanwhile, missions like ESA's Plato, planetary transits and oscillations of stars, are being designed with the express intent of finding Earth-like planets around Sun-like stars. These missions will not only seek out new worlds, but also aim to study their seismic activity, providing us with crucial information about their internal structures. Beyond these, we also have groundbreaking projects like the Breakthrough Starshot initiative, which plans to send ultra-lightweight spacecraft to our nearest star system, Alpha Centauri, in the hopes of finding habitable planets. But it's not just about finding new exoplanets. It's also about developing the technology to study them in greater detail. Scientists are constantly working on new techniques, such as spectroscopy, which could potentially allow us to detect signs of life on distant planets by analyzing the light that filters through their atmospheres. The importance of continuous research and innovation in this field cannot be overstated. With each new discovery, with each technological breakthrough, we inch closer to answering one of humanity's most profound questions. Are we alone in the universe? As we continue our cosmic journey, the discovery of a second Earth seems not a matter of if, but when. In the grand scheme of the cosmos, our existence is but a fleeting moment. Yet, within this moment we harbor the audacity and intelligence to reach for the stars, to explore exoplanets, in our quest to find extraterrestrial life. As we delve deeper into the secrets of the universe, the significance of these celestial bodies cannot be overstated. They are not merely distant worlds, but promising targets for discovery, holding the potential to revolutionize our understanding of life itself. Imagine the possibilities that lie in the uncharted territories of these exoplanets. Perhaps we'll find traces of life in forms we've never conceived, or perhaps we'll uncover the building blocks of life as we know it, reaffirming our cosmic connection to the universe. As we gaze into the night sky, we are reminded that the search for life beyond Earth is not just about finding aliens, it's about understanding our place in the universe.